I'm just so frustrated. What am I ever going to use chemistry in the rest of my life? I just don't understand.
Well, Bridget, little did you know that chemistry is used frequently in your everyday life.
But how?
I'll show you some examples.
When you cut an onion, you break cells, releasing their contents. Amino acid sulfoxides from the sulfonic acids. Enzymes that were kept separate now are free to mix with sulfonic acids to produce propane-thiol S oxide, a volatile sulfur compound that wafts upward towards your eyes. This gas reacts with the water in tears to form sulfuric acid. The sulfuric acid burns, stimulating your eyes to release more tears to wash the irritant away.
I bet you never knew that about onions.
Yeah, I just thought my mom was really passionate about cooking.
Let's take another look at chemistry in the kitchen.
The way to demonstrate an endothermic process is by baking a cake. As the cake batter absorbs the heat from the oven, it bakes the cake fully. The way to demonstrate an exothermic process is by letting a cake cool. The system, which is the cake, cools down by releasing heat to its surroundings.
I never thought of endothermic and exothermic reactions that way.
Isn't it crazy?
Yeah, it is.
Now let's take a look at how hydrogen bonding is relevant in your everyday life. Bridget is unaware why ice floats in water, but it's because water reaches its maximum density at 4 degrees Celsius. As it cools further and freezes into ice, it actually becomes less dense. On the other hand, most substances are more dense in their solid state than in their liquid state. Water is different because of hydrogen bonding. A water molecule is made from 1 oxygen atom and 2 hydrogen atoms, strongly joined to each other with covalent bonds. Water molecules are also attached to each other by weaker chemical bonds. Between the positively charged hydrogen atoms and the negatively charged oxygen atoms of neighboring water molecules, as water cools below 4 degrees Celsius, the hydrogen bonds adjust to hold the negatively charged oxygen atoms apart. This process, a crystal lattice, which is commonly known as ice. Ice floats because it is about 9% less dense than liquid water. In other words, ice takes up about 9% more space than water. So a liter of ice weighs less than a liter of water. The heavier water displaces the lighter water, so ice floats to the top.
Intriguing.
Yeah, I know. So you ever think about why soap cleans so good? Because if you are, let's take a look.
Soaps are made from long molecules that contain a head and tail. These molecules are called surfactants. Take a look at the diagram. The head of the molecule is attracted to water, and the tail is attracted to grease and dirt. When the soap molecules meet grease on hands, the tails are drawn into the grease, but the heads still sit in the water. The attractive forces between the head groups and the water are so strong that the grease is lifted away from the surface. The blob of grease is now completely surrounded by soap molecules and is broken into smaller pieces, which are washed away by the water.
That was really interesting. I just want to wash my hands right now.
You know when's a really good time to wash your hands?
When?
After Chem Lab! Ever be laying on the green grass on a summer day, looking at the sky, wondering why it's blue?
Every day.
Well, here's why.
The light from the sun looks white, but it is really made up of all the colors of the rainbow. All light travels in a straight line unless something gets in the way, in this instance to scatter it. Sunlight reaches Earth's atmosphere and is scattered in all directions by the gases and particles in the air. Blue light is scattered in all directions by the tiny molecules of air in Earth's atmosphere. Blue is scattered more than other colors because it travels in shorter, smaller waves. This is why we see blue sky most of the time.
Bridget, I told you you use chemistry in your everyday life.
Wow, now I understand why it's so useful.
You see, Bridget, I bet you never...
Another what?
Let's take another... Ever be laying on the grass?
Batter absorbs. As the pig.
Now let's take a look at how hydrogen...
What they do?
She's like walking and he's like, no, no, no. And she's like, this is my shirt. I do what I want. And she's like walking and it's lovely.
Made from molecules that contain a head and a tail.
All light travels in a straight line unless something gets in the way. In this case,